Okay people, this is a New York Skyline experiment proof of concept. The reason I'm doing this is because some people don't understand mathematics, they have some problem with it. So I'm doing this to show you that it doesn't matter how high up you are in elevation, and it doesn't matter in either case. It doesn't matter either for Bear Mountain or for the Empire State Building, how high up they are in elevation. All that matters is that the camera that I'm holding is level. That's what matters. If you have a level camera and it's pointing towards the Empire State Building, which we know has some level of inclination, in our case is 0.56 degrees, it doesn't matter how far away it is. All that matters is that I have a camera and I'm holding it level. If I'm holding the camera level, then I have more chances at capturing this inclination. If my camera is moving around and I'm tilting it up and down, what kind of inclination am I trying to capture? I'm not going to capture anything. It's an experiment in futility. So if you have a level camera and you're recording from any point, from any height at Bear Mountain, then the angle of incidence that it has on the surface of the skyline, on the surface of the Empire State Building, is going to be the same at any height on the Bear Mountain. Please note that our calculations are not affected by any drop due to the curvature of the Earth. The Empire State Building has a marked drop from the level of Bear Mountain. This red dotted guideline marks the level at which Bear Mountain sits. The base of the Empire State Building is much lower than the level of Bear Mountain. And we can see this here. We'll follow the red dotted line, and this is the base of Bear Mountain. There you go. That's our guideline. See? That's our guideline. So this method is not affected by any drop due to the curvature of the Earth. An angle of inclination is an angle that joins the two places together because they're joined at the hip, at the center of the Earth. The angle is not affected by any drop due to curvature. It's not affected by anything actually. As you can see, the angles are the same. This is the angle of incidence between my line of sight, which is level, 90 degrees. So this is the line of sight. It's at a 90-degree angle with the base where I'm standing. It's level, and in this way we can be guaranteed a constant and regular inclination at the other point, wherever we're pointing our camera at, and the angle is going to be consistent. As you can see, because I've inclined this rectangle, I've already inclined this rectangle at a 0.56 degree angle. The measurement done by CorelDRAW can measure the angle, and you can see it's larger than 90 degrees. If it was a parallel building, the angles of incidence would be 90 degrees. But you can see there's an inclination here. This building is inclined at 0.56 degrees away from what A perpendicular would be at Bear Mountain. It's easy. You don't need elevations. You don't need to know anything. As long as the object appears in the viewfinder of your camera. If the Empire State Building can be recorded from your position, if you keep your camera level, then Bob's your uncle. That's it. Try and find the inclination you're looking for. There. That's where you're gonna find it. Nowhere else. If you keep tilting your camera, you're not doing anything. You're just wasting your time. And mine.
New York City skyline, Midtown Manhattan. From Bear Mountain, New Jersey, 60 miles upstate. Where is the curvature? Where? No curvature. The buildings aren't curved over. Empire State Building is straight up. Straight.